And the clock has just hit 11:09 p.m., which means it's time for a chemistry video. Today we are talking about limiting and excess reactants and applying them to actual amounts of reactants using stoichiometry. Last video we talked about it in terms of like picture representations, which can represent amounts. However, we're going to be maybe dealing with not so even amounts. Our goals for the video, or what we're going to be talking about, is determining which is going to be limiting and which is going to be excess for a particular reaction using stoichiometry. If we can do that, we can then also predict how much product should actually be formed. Reminder of the definitions of limiting and excess reactants. Excess reactant is the boring one. It's the one you have so much of that it doesn't run out. Basically, you'll have extra left over at the end of the reaction. The limiting reactant is called limiting reactant because it limits how much product you could form. You'd love to be able to form more, but you can't because you literally run out of your limiting reactant. You use all of it up, so the reaction stops. So it limits how much product you can form. This is what a problem that's going to look like if it's going to ask us which is going to be limiting, which is going to be excess. A very clear sign that I'm going to be dealing with limiting or excess reactants some way or another is that you're going to be given amounts of two reactants. For example, I'm given 75.0 grams of carbon monoxide. That is a reactant. I'm given 15.2 grams of H2. That is a reactant. That is the sign right there. I'm going to be dealing with a limiting reactant calculation. The way limiting reactant calculations are going to work is I'm going to figure out how much of a product. They do not specify a specific product, so I get to choose. However, in this equation, I only have one to choose from, methanol. I'm going to say, how much methanol could I form if all 75.0 grams of carbon monoxide react? Then I'm going to figure out how much methanol could be formed if all 15.2 grams of H2 have reacted. Then I'm going to compare those numbers. And by comparing those numbers, I will be able to determine which is limiting and which is excess. So again, I'm going to say I have 75.0 grams of carbon monoxide. And I'm going to figure out how much methanol can be formed. So I'm going to say I have 75.0 grams of carbon monoxide. I'm going to say it is going to react. Its molar mass is 28.01 grams for every 1 mole of carbon monoxide. Based on the mole ratio, it's going to be 1 mole of carbon monoxide is going to yield 1 mole of methanol, CH3OH. And mole of methanol is in a unit that represents the amount of it. So I can stop there. I'm also going to say, let's say I have 15.2 grams of H2 and all of them react. I'm going to convert also to moles of CH3OH. So I'm going to say its molar mass is 2.02 grams for every 1 mole of H2. Based on the mole ratio is 2 moles of H2. It's going to give me 1 mole of CH3OH. That also represents the amount of it. When you put both of these in your calculators, you're going to get the value 2.67 moles. And you're going to get 3.76 moles. This tells me if 75.0 grams of carbon monoxide completely react, I will form 2.67 moles. If 15.2 grams of hydrogen completely react, I will form 3.76 moles. However, remember, the limiting reactant limits how much you can get. So it is going to be corresponding to the smaller number. So the limiting reactant is going to be the, again, reactant corresponding to the smaller number, which is 75.0 grams of carbon monoxide. So carbon monoxide is your limiting reactant. Basically, why that is this tells me when I make 2.67 moles of methanol, I completely use 75.0 grams of carbon monoxide. I do not have enough carbon monoxide to make 2.78 moles. I do not have enough carbon monoxide to make 2.79 or 2.70. I've run out. I cannot make more than this. This is a smaller number. I cannot make 3.76 moles. This is as many as I can make because I will completely run out. That means this and this reactant with the higher value is going to be excess, which means my excess reactant is hydrogen, H2 in this case. Be careful. If you just look at these gram values, hydrogen was the smaller value. So you might think, oh, that's going to run out first. Nope. Molar mass and the mole ratio has an impact. So if you just want to determine whether a reactant is limiting or excess, take both, convert to a product, does not matter which product, and then compare. Lower value corresponds to the limiting reactant, higher value excess. I'm going to show you another problem. I'm going to need to erase what I did. This problem is slightly different. It's going to say that I have 2.0 gram sample of ammonia being mixed with 4.0 grams of oxygen in react, and it wants to know the mass of nitrogen monoxide that's going to be formed. Well, this is also a limiting reactant problem. I can determine that and tell because I'm given 2.00 grams sample of ammonia. That is a reactant. And 4.00 grams of oxygen. That is a second reactant. I'm given amounts of two reactants. Big sign I'm dealing with a limiting reactant problem. It asks for the mass of nitrogen monoxide that's going to be formed. I cannot determine that without knowing which is limiting, which is excess. So that's the first thing I'm going to do, is figure out whether ammonia or oxygen is limiting, and the other one is going to be excess. Again, I'm going to do that by taking the amounts of each, 2.00 grams of ammonia and 4.00 grams of oxygen gas, which is O2, and converting each of them to a product. Now in the last problem, I only had one product to choose from, but they didn't specify, so I could have chose whichever. In this case, they explicitly specify nitrogen monoxide, so even though I have two products, I'm going to go with the one they give me. If they didn't say anything at all, then you could choose whichever one you want. But they specifically told me nitrogen monoxide, so that's what I'm going to go to. I'm going to convert using ammonia's molar mass, which is 17.04 grams of NH3 for every 1 mole of NH3. I'm going to use the mole ratio, which is 4 moles of NH3 for every 4 moles of NO. I'm going to do 4.00 grams of O2. I'm going to convert it to moles first using its molar mass, which is 32.00 grams for every 1 mole of O2. Its mole ratio is going to be 5 moles of O2 to 4 moles of NO. I put those values into my calculator. I get 0.117 moles of NO if 2.00 grams of ammonia completely react. But I don't know if that is a true statement or not. I don't know if all of this reacts. I put this into my calculator. It tells me that if 4.00 grams of O2 reacts, then I will get 0.100 moles of nitrogen monoxide. So now I do the comparison part. Remember, the limiting reactant or limiting reagent limits how much you could form. So it causes you to form the smaller number, which means O2 in this case is limiting. And NH3 is excess. The limiting determines how much product you could form. So I know 0.100 moles of nitrogen monoxide will be formed. Now I do have to be careful. The problem asked me for what is its mass, and this is moles. So I'm going to just do one last conversion, 0.100 moles of nitrogen monoxide to its mass value, which the molar mass is 30.01 grams of nitrogen monoxide. Oh, hold on. I'm doing the initial analysis wrong. I do want to use the molar mass, but if I put it there, it will not cancel correctly, and I won't get what I want. I need 1 mole of nitrogen monoxide down here to give me 30.01 grams of nitrogen monoxide. If I put that into my calculator, I basically get 3.00 grams of nitrogen monoxide. So while it can get more complicated when we're dealing with stoichiometry and calculation volumes problems, for limiting in excess, again, the definitions are fundamental. You need to know that the limiting limits how much product you can form because it runs out. So take the amounts of both reactants, convert them to an amount of a product, and then compare. The limiting limits how much you get and causes you to get the little smaller number. So oxygen, in this case, caused me to get the smaller number, so it is limiting. Ammonia and H3 caused me to get the bigger number, that is an excess. Take the smaller number if they ask for grams, and then just do one last conversion to get it in grams. So at the end of this reaction, I'm going to have some NH3 left over. I'm not going to have any O2, but I am going to have 3 grams of nitrogen monoxide. Give some practice for these problems before you get too drawn up on the dimensional analysis, the stoichiometry. Make sure you have a game plan, and you got to understand the conceptual definitions before you get too far into the calculations.